Yes, did you solve the problems? No. Very busy in making the cards. Did you complete the cards?
Yes, sir.
How many?
Still complete. 4
How many?
complete, 5 more we have to make.
Uh,
Project is also there, sir. Biology.
biology project. When you have to submit?
30.
30th of May.
Hmm. Okay. So shall we start new topic?
Yes, sir.
Yes. Anyone having any doubt regarding this calorimetry? No one got time to solve the problems of the book?
Solve then.
Huh?
Solving the problems of the book, then can we ask?
Okay, then we shall start this new topic, that is refraction of light. In class 9, we have done reflection of light. So reflection of light at plane surface, reflection of light at spherical surface, that is concave mirror or convex mirror. These all things we have discussed in class 9. Now here we are going to discuss another phenomena of light that we call refraction. What is light, you are knowing? We call light is form of energy that gives us sensation of vision or sight. So that is, so by light only we are able to see any object. Light itself is invisible. We can't see light. But when light falls on any object, that object is visible. The light, how it is coming from the sun to earth, that path is not visible. But when that sunlight falls on any object, that object is visible. So when you see the object, what is happening? The light is coming from object to your eye or from your eye to the object. Due to which light you are able to see? Light which is falling from your eye to the object, or the light which is coming from the object and enters into your eye?
From the object.
From the object, not from your eye. So in the dark room, when nothing is visible, you are using the torch, and torch you are pointing on the object, not on your eye. So light must fall on the object, and that reflected light from the object, or maybe itself, maybe the source, the transmitted light, or the so either transmitted or reflected, or itself is the source, emitted one from the source that enters into your eye, then you are able to see that particular object. Okay. So now when light falls on any, as we know, light is an electromagnetic wave, and its speed is how much? So this light we call
3 into 10 to the power 8 meter per second.
yes. So light is an electromagnetic wave. So electromagnetic wave means it is produced due to the vibration of electric and magnetic field. Like sound, it is produced due to the vibration of any surface. So it is not like sound. Vibration means continuous variation we call. So there is continuous change or periodic change in electric field as well as magnetic field. Then only this electromagnetic wave is originated. There are different type of electromagnetic wave. Separate chapter we have to discuss. We have got. So light is also one of the electromagnetic wave. And electromagnetic wave is very wide spectrum. Light, the visible region is very small part of that one. So this light we call, this is visible region of electromagnetic wave. Electromagnetic wave has got very wide spectrum. And this is very small region. So this has got a wavelength range of from 4,000 angstrom to 8,000 angstrom. Or sometimes we call 400 nanometer to 800 nanometer. The electromagnetic wave of this much wavelength, having the wavelength in this range, are visible region. Wavelength beyond this, different electromagnetic wave. So less than 400 or more than 800 nanometer, they are different wave. Among this only, we are having 7 different sub-regions. This visible region is divided into 7 sub-regions. That is divided into 7 sub-regions: violet, indigo, blue. So that we call Vibgyor. So these are sub-regions. That is, suppose for example, light of wavelength 400 nanometer to maybe 480 or 510, whatever it is. That is called violet region. More than that, some range is there. That is indigo region. 6200 to 8000. That is red region. So this has got highest wavelength. This has got minimum wavelength. So violet is not particular color. That is one region. Red is not particular color. This is red region. Means if you see the cloth of different variety of red is there. That is, they are having different, they are emitting or they are reflecting light of red color only, but they are of different wavelength. Maybe 6200 to 8000 angstrom, all are red only, but their appearance will be different. So that's why we are having variety of red, variety of green. All green are not same. So that we call a particular region. So this visible region is divided into 7 sub-regions. So among this, violet has got minimum wavelength, red has got maximum wavelength. Okay, so this is visible region. Now one more thing we have to know, in class 9 we have done, what is the relation between speed, wavelength and frequency? In class 8 also we have done, in class 9 also we have done, in case of sound. What was the relation? What is relation between speed, wavelength and frequency? Anyone? Can you recall? No, forward. Since we are studying only to vomit in
What,
exam.
sir?
Huh?
N lambda.
What is that?
Please repeat the question, sir.
What is relation between
To n lambda.
speed, wavelength, and frequency of sound wave? That we have done in class 8, that we have done in class 9. What is the
Frequency,
relation?
M lambda. or something like that.
frequency is equal to n lambda.
Frequency
Frequency
and lambda. Okay, what is n? No idea. Any other? This is the result when you learn without understanding. In physics, understanding is important, but you are habituated of learning get by heart anyhow, and we will vomit in the exam. Somehow we have to pass in exam. That is our purpose. No need to understand anything. Simply learn. 2 days before exam, we will start our study, and after exam, we will forget everything. So relation is, this speed is frequency into wavelength. So C is, or V, whatever symbol you have used, this V is n lambda, or sometimes we say C is nu lambda. Whatever relation you have learned, C is speed of wave, nu is frequency, and lambda is wavelength. Frequency means 1 by time period, time taken to complete one vibration. So in sound, there is real vibration that we can visualize that vibration. But here in case of light, we can't visualize it. So that what is the time period of that electric field, after what time it is repeated, that is its time period. Inverse of that time period we call frequency. And wavelength, distance between two consecutive crests or two consecutive trough, or two consecutive compression or two consecutive rarefaction. In case of longitudinal wave, as sound is longitudinal wave, so it will be distance between two consecutive compression or two consecutive rarefaction. Whereas in case of transverse wave, which is in the wave which is formed on the water, the ripples which is formed on the water, the distance between two consecutive crests, you might have seen the rings. So that crest means maximum displacement, heap, that is crest. So distance between two consecutive crests or distance between two consecutive trough. So light is also a transverse wave in nature. Sound we call longitudinal wave, light transverse wave. But there is no comparison between sound and light. Sound is different, completely different. Sound we call elastic wave because it requires material medium for its propagation. Whereas light we call electromagnetic wave. It does not require any medium. It can travel through vacuum also. It don't require any medium. Its speed is very high. The speed of sound in air is 330 meters per second approximately. In steel, nearly 5,000 meters per second. Whereas speed of light in vacuum or in air is how much?
3 into 10 to the power 8 meter per second.
3 into 10 or 8 meter per second, or 3 lakh kilometer per second. So in 1 second, it can travel 3 lakh kilometer. So its speed is tremendous.
3 lakh kilometers.
Yes. What happened? So speed of light in air or vacuum, you can say. C naught is how much? 3 into 10 to the power 8 meter per second. In air, it is slightly less. So speed is very high. Okay. Now, when light falls on any surface, when light strikes on any surface, suppose light is coming from the LED bulb and it is striking this surface, or it may strike some other surface. So what is happening? What are the different possibilities? Suppose it is striking on this surface also, as well as this surface. So what is happening here? The light which has fallen on this surface is absorbed. That's why it is appearing black. No light is reflected. So it is absorbed. Whereas the light which has fallen on this surface, what is written beside C, where is that? C naught we call 0, means no medium is there. So vacuum C naught or CA, sometime we write C naught or CA means air. Not we represent 0, we represent that is no medium, that is vacuum. And CA we write. Similarly, CG means speed of light in glass. CW, speed of light in water. These are the common symbols, but not standard symbols. So, when light falls on any surface, different possibilities are there. One is the surface may appear dark due to what? The light is completely absorbed by that surface. When light is falling on this surface, what is happening? On this whiteboard, when light is falling, what is happening? Some light are reflected, whereas some are absorbed. If it falls on very smooth surface like mirror, most of the light is reflected. So depending on the nature of the surface, what will be the situation that will come. Now suppose light is falling on here, this place, in air. What is happening here? The light is transmitted. Now in this case, in this region, what is this region? Suppose we say the light is falling on this region and it is transmitted to other part. Or if it is a glass plate, it is striking and it is transmitted. So there are three possibilities or three phenomena are there which may occur when light falls on any surface. And these three phenomena are what? Reflection, refraction, transmission we call. So transmission and then absorption. So when light falls on any surface, so three things may occur. What are the things? Three phenomena may occur. So one may be reflection, absorption, and the third one is transmission. Or their combination. When some light is absorbed, some is reflected, some is absorbed, some is transmitted, some is reflected. That may be also there. when we are taking the glass plate. Some is reflected also because we are able to see the glass plate. If it is not reflected anything, glass plate will become invisible. Like here, air is invisible because light is not reflected. Now suppose in place of this air, some smoke is produced here. We are able to see the smoke. That means that smoke is able to reflect some light. So if light is reflected, then only that object will be visible. If it is not reflecting, object is invisible. So here in this case, air, all light are transmitted only. No reflection, no absorption, we can say almost. If it is falling on glass plate, some light is absorbed, some light is reflected, and some is transmitted, or most of the light we can say transmitted if it is transparent glass plate. If it falls on the mirror, most of the light is reflected, some is absorbed, negligible is transmitted as it is. Back surface is colored or polished, so no light will be transmitted. It is either reflected or absorbed. So these three phenomena may take place. Theoretically, we can say only reflection, only absorption, only this, but practically what will be? Combination will always take place. There is no surface which is transmitting 100% light. Here also, when it is passing through the air, some light is absorbed also. That's why the intensity will keep on decreasing. When you go far away from this LED, the intensity of the light is very less. Only air is present everywhere, but then also intensity keep on decreasing. When the paper is kept very close to the LED, much bright is there. So it is absorbing also. So practically there will be combination of more than one phenomenon. Now here we are going to focus on this phenomenon when light is transmitted from one medium to other. In class 9 we have focused on this phenomenon, reflection. That is, in case of plane mirror, in case of spherical mirror, we have discussed this reflection one. Now in class 10, we are going to focus mainly transmission of light. So when light goes from one medium to other, what will happen? So while going from one medium to other, light bends from its original path. It is not following the same path. And this bending only we call refraction of light. So how we define refraction of light? So we call the bending of or deviation of light from its original path. While going from one optical medium to other is known as refraction of light. So bending of light from its original path while going from one optical medium to other. So optical medium means what? The medium through which light can propagate, can pass, that we call optical medium. So all the transparent medium we call optical medium. That means when light is going from air to water, air to glass, or water to glass, in that case only this phenomena will take place, when there is change in optical medium. So when it goes from one medium to other, it will bend from its original position. So why it bends? In class 8 we have done. What is the cause of bending of light? So as the speed of light, speed of light is different in different media. So it takes the path through which it can cover that much in minimum time. So it will change the path so that it can move or it can cover that medium in minimum time. So main is the speed of light is different in different medium. So reason is so when light goes from one medium to other, sometimes we ask, what are the physical quantities that change? So when light goes from one medium to other, its speed will change, its wavelength will change, its intensity will also change, brightness of light will also change, because some of the light will always be absorbed. So when light from one medium to other, of course optical medium is it, one optical medium to other, its speed, wavelength, and intensity changes. This speed and wavelength may increase or may decrease depending on from which medium it is going to which medium. Whereas the intensity will always decrease, whether it is going from one, whatever the medium may be, the intensity will always decrease because some of the light will always be absorbed. So speed and wavelength may increase or decrease depending on medium. But intensity depending on two medium, from which medium it is coming and from in which medium it is going. But intensity will always decrease. Because some light will always be absorbed. So intensity will never increase. Now, which quantity will not change? That is the frequency. So number of vibration per second that will not change when sound is going from one medium to other, or when any wave is going from one medium to other. That frequency will not change. So frequency of light remain unchanged. When it goes from one medium to other. So frequency will not change. Remaining thing will change, but frequency will remain constant. This point is very important. Sometimes we ask, name the physical quantity which remain unchanged when light goes from one medium to other. Or while solving numerical also, this concept we use. So wavelength may change, velocity may change. Now this, because this frequency depend only on the source. Unless we change the source, how many vibration will produce? Suppose someone we are striking the water surface, you may strike very slow or you may strike very fast. That will depend only on you. So how many waves are produced per second? That will be depending on the source, how you are striking. So frequency of light remain unchanged when it goes from one medium to other, because it depends only on source. It depends only on source. If you are not changing the source, frequency of wave will not change. Whether it is sound wave, whether it is light wave, whatever the wave may be, the frequency of wave will depend only on source. It does not depend on the nature of medium. Whereas the remaining two, the speed and wavelength, will depend on both. Speed and wavelength depend on nature of medium. Wavelength also depend on the source, because frequency changes, that means wavelength will also change. So wavelength depend on source also, but frequency only on source, nothing else. Frequency does not depend on the medium. Okay, so we'll leave up to here. Next we will start this different situation when light goes from denser to rarer, rarer to denser. This we have just discussed in class 8 also. So, and then main part of class 10 syllabus will start. That is refractive index, and then laws of refraction. Okay, so we'll leave up to here.
Thank you, sir.
Anyone having any doubt? No doubt. So you solve the problems of calorimetry and ask
Okay.
your doubts.
Okay, sir.
Okay,
Sir.
thank you.
Thank you, sir.
Hmm.
Sir,
What is the problem? Ask.
sir, sir,
Whatever.
whatever you are giving the notes, I am writing in an
No
oblique.
problem.
Is it okay?
Oh, no
Thank
problem.
you, sir.
These notes are for your convenience. You can whatever you are doing exercise, that is in fair copy. You have to separate copy. You have to make.
Okay, sir.
Okay, thank you.